All right, hi everybody. So this was the question that was asked from homework 1C, I believe. This is number 37. So it says a squirrel completing a short glide travels in a straight line. So we know it travels in a straight line. Tipped 40 degrees below the horizontal. I'm going to talk about this phrase here in just a minute. So it says the squirrel starts at 9 meters and then 9 meters above the ground. And then glides to a second tree that's 3.5 meters away. What is the length of the squirrel's glide path? So one of the big things that's going to help here is to draw a picture of what you think is going on. So I drew a picture of my two trees. I know the squirrel started at a height of 9 meters, so this is where the squirrel starts. This is kind of, I like to label, it's good to label what your initial moment is and what your final moment is, so that's kind of what I'm doing there. And then I know the distance between the trees is 3.5 meters away. And then lastly, I labeled the height of this tree because I think that's going to show up again in part B. So the one thing that probably ends up being an issue with a lot of students is that what's the angle? What angle do I choose? And so what I did here, this dashed line here, is what we call a horizontal. I could very well, it's just making any sort of horizontal line. So sort of, any horizontal line like that. It could be anywhere. I could put it anywhere, but typically I do it here, and I'll talk a little bit more about that. I could have used this that I drew as well, but yeah. So what do they mean by 40 degrees below the horizontal? Well, let's say you had an arrow pointing to the right on the horizontal. To go 40 degrees below the horizontal would be if the arrow suddenly got shifted down to this new position, so it just rotated the arrow so that it's now 40 degrees below where it was before. And that's what we mean by below the horizontal. So if I have a horizontal, 40 degrees below would be like that. Where 60 degrees would be something like this, right? That would be, so this angle here would be a 60 degree angle below the horizontal. We're being above the horizontal, this would be like 30 degrees above the horizontal. So just kind of showing that notation there. All right. So let's go ahead and solve this problem. So what is the length of the squirrel's glide path? So basically I'm looking for the displacement, which is this right here. So that's my displacement, and I'm trying to find out exactly what that is. Well, I could use some trigonometry here, because I got basically a triangle here. Hopefully you can see my triangle. And so I'm purposefully kind of dropping down here. This is a 90-degree angle. This is 40 degrees right here. So I could use some trigonometry and use this triangle that I've made to find out what the displacement is. So if you've forgotten your trigonometry, SOHCAHTOA. And what this is basically telling me, this part's telling me that the sine of some angle, so taking the sine of something is basically taking the ratio of sides. So this is an operation that you can perform in your calculator. If I go to Desmos, I want scientific calculator. And if I write in sine of some angle, like 30 degrees, I get a ratio of 0.5, where sine of 60 degrees gives me this. Sine of 75 degrees gives me that. I can even do sine of 90 degrees, gives me 1. So it's always a ratio, and sines and cosines are always a ratio between 0 and 1. Well, I should say -1 and +1, or the magnitude is between 0 and 1. So sine of my angle here, this is what SO does, is the opposite over the hypotenuse. Cosine of my angle is the adjacent over the hypotenuse. And then tangent, these are all operations on your calculator, is equal to opposite over adjacent. Where if I have an angle, the opposite side of the angle would be here. So this is always my opposite side. This over here is the hypotenuse. That's the biggest part of the triangle. So the adjacent means next to. So it's next to the angle, but it's not the hypotenuse. So next to the angle, but not the hypotenuse, that would be this. This is the adjacent side. So I'm looking for delta x, And I know my angle, so that means I know kind of this side. I know, this side of the equation. I know my angle, and I know my adjacent side. So I know I could say here and here. And I'm looking for, though, the hypotenuse. So if I know my my cosine of my angle, and I know the adjacent, then that means cosine is going to be the one that's going to be best for me because I'm looking for the hypotenuse. So I'm going to use that to solve this problem. So here's part A. I'm going to use cosine of my angle is equal to my opposite, or sorry, my adjacent, which is 3.5 meters, divided by my displacement, which is the hypotenuse. So now I'm going to isolate delta x. So I need to get rid of, I need to undo, delta x is in the denominator, so I need to get delta x out of the denominator. A good way to do that is multiply both. So you got to undo that division. So I multiply both sides by delta x. Delta x cancels out, and I get delta x cosine of theta equals 3.5. Next up, I'm going to divide both sides by cosine theta. So cosine theta cancels out, and I get that my displacement, delta x, is 3.5 divided by cosine of my angle. So let's plug in all those numbers now. Delta x is equal to 3.5 divided by cosine of 40. And I get a displacement of, so 3.5 divided by cosine of 40. 3.5 divided by cosine of 40. Close parentheses, hit enter. I get about 4.57. So you want to round to about 3 or I think the book actually uses 2 sig figs, but we'll say 4.57 meters. Double check that. 4.57, yeah. All right. Whoops. So next up, so that was part A. Did part A. Nailed it. And then lastly, what is the squirrel's height above the ground when it lands? So that's what I've labeled here, which is h. That's the height of the squirrel above where it lands. So, right, because it's going to land here, but then there's some height above that we can find. So I'm going to solve this one. I'll call this, I don't know, I'll call it y. I'll call this y right here. So that's the distance between here and here. Let's make that a little. So I'll call this y. And so I'm going to solve for y, and once I got y, I know that I'm going to say basically, so this is all part B. From my geometry here, I can see y plus h is equal to 9, right? Because this is 9 meters right here. So, so I'm going to find y. Now, I'm going to use, again, a trigonometric function, or I could use Pythagorean theorem, but I'm going to use trigonometry because it's easier for me. I think I'm going to use tangent. I'll use tangent, opposite over adjacent. So, so I'm going to use tangent of my angle is the opposite. The opposite in this case is what I'm calling y, over my adjacent, which is 3.5. Isolating y, I'm going to multiply both sides by 3.5. And then I get 3.5 tangent of my angle is equal to y. So then 3.5 tangent of 40 is equal to y. And that's going to give me, so 3.5 tan 40. Uh, 2.94 meters. However, that's not my answer. That's my change in y right there. They want to know how high I am above the ground. So I'm going to subtract that from 9 meters, because basically using this equation from over here, I can say h is equal to 9 minus y. So that tells me h is equal to 9 minus 2.94, which is, I'm just going to use the calculator, 9 minus 2.94, 6.06, so about 6.1. Yeah, we'll say 6.1, why not? So 6.1 meters above the ground. And there you go. All right, bye.